Hello, my name is Tammy Surratt, and today I will be giving an overview of my paper for CIS 5345. The topic of my paper is extraction of XML from the web. Originally, I had started researching the topic of the relationship of XML and big data, but as I started researching this topic, I realized that it was certainly too broad and I needed to scope my topic down. And one of my subsets was data mining, querying, and extraction of data from the web. So that is what I will be talking about today. Before I get started on some of the data extraction techniques that I researched, I want to give a little background to some of the challenges that we experience with the extraction and also in many of the other things we do with XML. In its original design, XML was not designed to handle all the large amounts of data that we see today. It was originally designed as an offshoot of the standardized generalized markup language, SGML, intended to be used within the publishing industry. After SGML came along HTML, which was greatly popular, but it was adopted very quickly, and it almost started to being used outside of its original vision. So there left a gap with the data, and XML fills this gap. So today, XML is the standard language for the majority of our web data. So we see the large amounts with, all of our websites, social media sites, Twitter sites. Even it serves as the base of many of our BDPs, our big data platforms. It is the base of this knowledge. So what I decided to take a look at is how we can better harness some of this information, both on the standard web and also the deep web. In researching, I ran across an interesting fact that the deep web, or also referred to as the hidden web, has been estimated to contain 500 times as much data as the surface web. But the problem with the deep web is there are no URLs linking this data. So that's why in the one particular research paper I looked at, the authors explained, one, some of the current methods of extracting this data, as well as a hybrid approach that they are taking a look at to more effectively and accurately grab this data from the deep web. So some of the current methods, as laid out in this article, that are used to extract this data are, one, the surfacing approach, which analyze the deep web source to identify its HTML forms, and it uses a crawler method to basically query the fields and the values associated with the domain name of the deep web source. So that's the first one. And then there's also the crawling approach, which it's another approach that extracts all of the data from the analyzed deep web source and stores it in an external database. Now, the downside of this particular approach is it requires storage space. And depending on the large amount of data that is being extracted, that could become quite costly or, out of bounds, depending on the amount of data being extracted. And the authors also talk about a couple more specific methods that fall into the crawling approach, but due to time, I'm not going to be able to touch on each and every one of those in this presentation. And another major approach is the form integration approach. Now, advantages to this approach is it does not need to store the data. And the principle of this approach is to generate only one global form to query a set of deep web sources. This source and approach is more adapted to deep web features because you access the deep web based on its HTML form. And as I mentioned before, it does not need to store all of the data. So in comparison of these two mentioned approaches, they're very similar, and in 90% of the cases, as cited in this paper, they are typically referred to as a crawling approach. So what the authors are doing in their approach, they are trying to use and enrich during the process private knowledge about the deep web domain names. And in doing this, they have some algorithms that they've designed to identify and extract the most used words from the deep web source URI, and then basically build on that data and maintain almost a directory of this domain data. And then they only retain the HTML tables where they can extract new labels with a defined data type and new relations between the existing tables. And in summary, I guess, for this particular approach, again, it identifies a domain name using identification tables, and to the best of their knowledge, utilizes all the accessible elements of the deep web source and the external private knowledge that is being compiled. So this was one interesting article that I ran across, and another one of the articles that I used as one of my references uses a software. It is Andy software is the name of the software. And with the Andy software, it can be used on both the traditional web, and it can be used to extract data from the deep web. So what the Andy's software does is it provides a framework that makes significant advances in solving the problems and provides a platform for building a production quality web data extraction process. It's based on XHTML and XSLT, and it can exploit templates, path expressions, regular expressions for more effective data extraction, mapping, and aggregation. The ultimate goal of this this software is to be able to extract both semi-structured data from given websites and transform the data into a well-structured, feature-rich representation. So this is my paper, very brief overview. I know with the limitation of time I can't go into a lot of the details and complexities of some of the techniques, but I think in summary, I think the important thing as my takeaway in researching this is that I know in a bunch of our assignments and discussions, we often spoke about is XML relevant? And I would say yes, it is very relevant, and I think it is so tightly ingrained into all of our data sources that I do not think we will be seeing XML go away anytime soon. And I think another takeaway of this research is that there are ongoing aggressive research to both improve the optimization and of extracting XML data, and to make this data more accessible and valid in our information data research. Thank you very much. I look forward to any input you can give me on this presentation. Thank you.